Namaskar, I am Dan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the examples on principle of least action. A system of two degrees of freedom is described by the Hamiltonian H is equal to Q1 P1 minus Q2 P2 minus A Q1 square plus B Q2 square. A, B are constant. So that P1 divided by A Q1 P1 minus A Q1 divided by Q2. P2 divided minus B Q2 divided by Q1. Q1, Q2, H are constant of motion. Solution. The Hamiltonian of a dynamical system is given by H is equal to P1, P1 minus Q2, P2 minus A Q1 square plus B Q2 square. A, B are constant, where we see that Q1, Q2 are generalized coordinate. The Hamiltonian canonical equations of motions are Pj is equal to minus del by h dou h by dou Pj. P1 is equal to 2a Q1 minus P1. P2 is equal to P2 minus 2b Q1. And Qj dot is equal to dou h by dou Pj. Q1 is equal to Q2. Q2 is equal to minus Q2 dot is equal to minus Q2. Now to show that P1 minus A Q1 divided by Q2 is a constant of motion, consider divided of P1 minus A Q1 divided by Q2 is equal to Q2 P1 dot minus A Q1 dot plus P1 minus A Q1 Q2 dot divided by Q2 square. Using equation 2 and 3, we obtain divided of P1 minus A Q1 divided by Q2 is equal to 0. P1 minus A Q1 divided by Q2 is equal to constant. Similarly, we prove that P1 minus A Q1 divided by Q2 is equal to constant. P2 divided by B Q2 divided by Q1 is equal to constant. Q1 Q2 is equal to constant. Now to prove that the Hamiltonian H is also constant, we differentiate equation 1 with respect to t to get dH by dt equal to Q1 P1 plus Q1 P1 dot minus Q2 dot P2 minus Q2 P2 dot minus 2a Q1 Q1 dot plus 2p Q2 Q2 dot. Using equation 2 and 3, we see that dH by dt is equal to 0, therefore H is constant, and this shows that H is constant of motion. Example, a Lagrangian for a particle of charge q moving in an electromagnetic field of force is given by L is equal to 1 by 2 mv square q of v bar dot a bar minus q pi. Find the Hamiltonian H and the generalized momentum. Solution. The Lagrangian of the particle moving in the electromagnetic field is given by L is equal to 1 by 2 mv square plus q v bar dot a bar minus q pi. We write this expression as L is equal to 1 by 2 m x dot square plus y dot square plus z dot square plus q x dot ax plus y dot ay plus z dot az minus q pi, where phi is a scalar potential functions of coordinates only. We see that x, y, z are the generalized coordinate. Hence, the corresponding generalized momentum, because Pj is equal to dou L by dou Qj dot. Therefore, Px is equal to mx dot plus Qax, Py is equal to my dot plus Qay, Pz is equal to mz dot plus Qaz. Solving this equation for velocity component, we get x dot is equal to 1 by m Px minus Qax, y dot is equal to 1 by m Py minus Qay, z dot is equal to 1 by m Pz minus Qaz. The Hamiltonian of the particle is given by H is equal to summation of Pj Qj dot minus L. H is equal to x dot Px plus y dot Py plus z dot Pz minus 1 by 2 m x dot square plus y dot square plus z dot square minus q x dot ax plus y dot ay plus z dot az plus q pi. Eliminating x dot y dot z dot from equation 4 by using equation 3, we get h is equal to 1 by 2 m px square plus py square plus pz square minus q by m px ax plus py ay plus pz az plus 1 by 2 m q square into ax square plus ay square plus az square plus q pi. This can be written in vector notation. H is equal to 1 by 2 m p bar minus q a bar bracket square plus q pi. This is the required Hamiltonian of the particle moving in the electromagnetic field. The Hamilton equations of motion Qj dot is equal to dou H by dou Pj give the same set of the equation 3, while the equation Pj dot is equal to minus dou H by dou Qj gives Px dot is equal to minus dou H by dou x is equal to Q by m dou by dou x Px Ax plus Py Ay plus Pz Az minus Q square divided by 2m dou by dou x of Ax square plus Ay square plus Az square minus Q dou pi by dou x. This can be written as Px dot is equal to Q dou by dou x of V bar dot A bar minus Q dou pi by dou x. Similarly, other two components are given by Px dot is equal to Q dou by dou y of V bar dot A bar minus Q dou pi by dou y. pz dot is equal to q dou by dou z of v bar dot a bar minus q dou phi by dou z. All these three equations can be put in the single equation as p by dot is equal to minus q del phi plus q del of b bar dot a bar, and this is required equation.